Hello my dear friends, welcome back to CSIR at home. Folic acid. Folic acid is composed of three constituents. Pteridine group linked with para-aminobenzoic acid. It forms pteroic acid, then attached to glutamic acid to form pteroyl glutamic acid. That is folic acid, pteroyl glutamic acid. Recommended daily allowance for folic acid 200 mg per day. During pregnancy and lactation period, it is 400 mg per day. Sources of folic acid: green leafy vegetables, yeast, cereals, pulses and egg. Folic acid is absorbed from the upper part of jejunum. This is very important, okay? Upper part of jejunum. Biochemical functions of folic acid. Its most important use in the body is in the synthesis of purines and thymine. The purines and thymine, which are required for DNA synthesis, okay, DNA formation. Therefore, folic acid is required for replication of cellular genes. It's needed for growth. Okay. Folic acid is reduced to dihydrofolic acid. Then this dihydrofolic acid further reduced to tetrahydrofolic acid with the help of enzyme NADH dependent folate reductase. Tetrahydrofolic acid, it's a carrier of one carbon groups. Then the synthesis of active methionine, folic acid is necessary, okay? Deficiencies. Macrocytic anemia. During RBC generation, if folic acid is deficient, what happens? DNA synthesis delayed. Okay, DNA synthesis delayed if folic acid is deficient when during RBC generation, but protein synthesis is continued. Okay, thus hemoglobin accumulates in RBC precursor. Hemoglobin is a protein, you know. Thus, the hemoglobin accumulates in RBC precursors. But DNA synthesis delayed. This will result in immature looking nucleus and mature eosinophilic cytoplasm, where in bone marrow. Okay. So, reticulocytosis is seen. What is reticulocytosis? That is immature red blood cells. Increase in reticulocytes, that is immature red blood cells. The amount of immature red blood cells is increased. That is known as reticulocytosis. So, during RBC generation, folic acid is deficient, DNA synthesis delayed, but protein synthesis continued, resulting in immature looking nucleus. At the same time, eosinophilic cytoplasm is mature. Okay. These abnormal RBC are destroyed in spleen. Okay, so reduced generation and increased destruction of RBC lead to anemia. Abnormal RBC are destroyed in the spleen. This condition lead to anemia. This one is known as macrocytic anemia. Hyperhomocysteinemia. This condition occurs when homocysteine level in blood increases. If it is increases above 15 mmol per liter, this level is known to increase the risk of coronary artery diseases. Birth defect. Folic acid deficiency during pregnancy may lead to neural tube defect in fetus. It's known as spina bifida. Folic acid deficiency contribute to the etiology of bronchial and cervical carcinoma. Now we can study what causes folate deficiency. Folate deficiency is very common when during pregnancy. Folate deficiency is common. Why? The requirement is increased. Then defective absorption. Folic acid is not absorbed properly. You know, the absorption of folic acid, vitamin C is needed. For example, in celiac disease and gluten-induced enteropathy, this folic acid is not absorbed. Okay, the absorption is impaired. Then drugs. Drugs inhibit intestinal enzyme that remove glutamate residue from folic acid. Monoglutamic acid form is absorbed. Then hemolytic anemia, it causes folic acid deficiency. Then dietary deficiency, that means absence of folic acid in our diet. Then the folate trap. Folate trap means when B12 is deficient in our diet, it will lead to folate deficiency that we can study. If you like this video, please like and subscribe. Thank you.